All right, in this video, we're going to work through the following indefinite integral. We have the indefinite integral of the seventh root of the quantity cosine x plus 1 times sine of x dx. Okay, so looking at this integral, we can see that it is definitely not one of the basic integrals. It's not just some derivative fact that we have to do in reverse. It is more complicated than that. And so that, for our class, that essentially means that we're going to do this by substitution, right? And so for substitution, we need to pick a value for u. And at the top of the list of good choices for u are expressions that are inside other expressions. And so you can see this cosine x plus 1 is inside the root here. So that makes it a good candidate for being a good choice for u. Another thing that really helps is if I take the derivative of cosine x plus 1, I get minus sine x. And you can see that that derivative is a factor of the integrand. It's just being multiplied times this other stuff. So that makes it also a very good choice. And you can see it's not exactly the derivative of cosine x plus 1. It's off by a minus sign. But being off by a constant multiple like -1 in this case is not so bad when it comes to that. And so all of that is going to lead us to say, hey, we're going to try cosine x plus 1 as our choice for u. And once you choose the u, right, then calculate your du. You do that just by taking the derivative of both sides and then putting a du over here and a dx over here. The derivative of u is just 1, so 1 times du is just du. And then taking the derivative of cosine x plus 1, that's going to be minus sine x plus 0, which I'm not going to bother to write. All right, and then I'm going to multiply that by dx here. Okay, and so you can see things are pretty good. Our next job then is to use these two equations to transform every instance of the variable x into some corresponding version involving the variable u. All right, so this cosine x, I've got to take care of this cosine x plus 1. That's pretty straightforward because that's what we picked to be u. So this cosine x plus 1 will just be replaced by u. Then over here I have sine x dx, and I'm obviously going to use this equation, right, with the dx in it to replace the dx here. You can see that I have sine x dx, but I do not have a negative sign with the sine x. And that is very, very easy to fix when you're off by a constant multiple like that, because you can just multiply both sides by a -1, right? So I multiply this left side by a -1, I get -1 times du. When I multiply the right side by -1, I have -1 times this minus here. That's just going to become sine x dx. Like so. Okay? All right, so now everything looks pretty much perfect here. I'm going to go ahead and substitute cosine x plus 1. That's going to be u to the 7th power. And then sine x dx, I have that exactly right here. And I know that in terms of u, that would be -1 times du. Right, so I'm just replacing sine x dx with what it's equal to here. And you can see that leads to this pretty simple integral. In fact, this is just going to be another power rule here. All right, so now turning our attention to calculating this indefinite integral, the first thing I'm going to do is to use the constant multiple rule, right? The constant multiple rule says that that -1 can come out in front of the integrand, right? If I have the integral of a constant times a function, that's equal to that same constant times the integral of the function part here. Now the function part is going to be the 7th root of u, so you can write that as a power function. It's going to be u to the 1/7 power. And it's better, right, to write that way because this is a power function, and so we are going to use the power rule to take the antiderivative of that. All right. So what I'm going to do then is to add 1 to the power. 1/7 plus 1 is 8/7. and then I'm going to divide by 8/7 or equivalently multiply by the reciprocal of 8/7, which I encourage you to do on this one since it's a fraction, which is 7/8, right? Dividing by 8/7 is the same as multiplying by the reciprocal, right? Which is 7/8. And then don't forget the plus c. Here I would simplify this if I could, but there's nothing really to simplify here. And so all we're left to do here is to back substitute. And so we're going to replace u by what it's equal to, so that our most general antiderivative, or indefinite integral, however you want to say it, is written with the same variable as the original problem. So the final answer on this one is -7/8 times the quantity cosine x plus 1 raised to the 8/7 power plus some constant c.